Okay, so our first example, we're going to look at y equals 5 cosecant x. We can recall some other information and say that our amplitude is 5 and our period is just, the b is a 1 here, so our period is 2 pi. So just some quick notes. Our amplitude is 5 and our period is 2 pi. There's no phase shift going on, so this is a very basic one. And we could also recall that this is the reciprocal of the sine. So if I wanted to do a real quick sketch, I could basically depict the sine graph, okay? And then if my amplitude is a 5, I could do a rough sketch in this manner with the dash part being representing 5 cosecant x. But let's be more precise than that. Let's calculate values. So let's take an x value. Let's let x equal 0. And I have my y equals 5 cosecant x. Let's plug in 0 for x. So I would have 5 times the cosecant of 0. So let's put that in, use your unit circle and get that calculation. Good, so if you go to cosecant of 0, which is the 1 over the sine, so we recall, let's just real quick recall cosecant of x is equal to 1 over the sine of x. So let's go to where sine is 0, it's going to be 0, so that would be 1 over 0. So this particular point would be undefined here. Let's do when x is equal to pi over 2. Okay, so then that would be y equals 5 times the cosecant of pi over 2. So go to pi over 2, and what's the y value is 1, so that would be 1 over 1. So what is the cosecant of pi over 2? Just 1, and then of course for this calculation it's multiplied by 5. So this ordered pair would be when x is pi over 2, y is 5. Okay, and that would represent this position right here on our rough sketch. Let's check pi. So when x is equal to pi, that would be y is equal to 5 times the cosecant of pi. Okay, let's go to the pi value on our unit circle, which is over here. And what do you get? Right. Yeah. Let me do it in blue. So then let's do when x is pi, let me do it in black. When x is 3 pi over 2. Okay, so when we get x is 3 pi over 2, we'll plug that in. So we will say y is equal to 5 times the cosecant of 3 pi over 2. We go evaluate that at 3 pi over 2, and that would give us what? -1, which then is multiplied by 5, so that's going to be the y value of -5. So x value is 3 squared, 3 pi over 2, y value is -5, and so on and so forth. So you could pick particular values, but it suffices to be able to make rough sketches of our parent graphs and then apply that information to there. Okay, so we jump from a very most basic, just basically something we can look at a parent graph and, let me delete this, apply some of that just to get a rough sketch. So this is a very basic baby version and just a generic algebraic representation, but let's come over here to something that's way more complex, okay, and try to get an established procedure for this. So let me recall that this is going to be a cosecant bx plus c, right? Well, we recall with transformations, what was going on here with a transformation? Shift it to the left pi force, but what about this plus one guy? We haven't seen that in a while, but we have seen this in transformation. It's just a horizontal shift. So in addition to a vertical shift, in addition to this thing shifting left and right, it also has a shift up as well. So let's just take one step at a time and recall some of our previous information. So amplitude is just going to be what? Absolute value of that, which is just 2. Let's collect data that we know. Period is 2 pi over b, which is going to be 2 pi over, what's b in this case? 1, which is just 2 pi. So we do have a phase shift going on. So this is going to be negative c over b, which this is negative pi over 4, and our b in this case was 1, so our phase shift is to the left pi force units. We have a vertical shift, which is new in this, a vertical shift of up 1. Okay, now let's try to be more precise in the points that we pick, which we'll come back over here and I'll need to keep this information in mind. But let's make a note and let's count our x values by a fourth of the period, just so that we have a consistent where do we go next to check the value. So a fourth of our period. What was our period? What do we say our period was? 2 pi. So we're going to break that up into even increments and just whatever x value we start with, we're going to increment by pi over 2. Okay. A good rule of thumb is to, when there's a lot going on, is to start with the phase shift. I'm just making a lot of extra notes. Start with the phase shift and count by increments that we chose above. Okay, that we selected. And we basically select our increments by saying, let's break it up into 4 so we get a good precise graph of whatever our period. This will be our increments. We'll start with our phase shift and count by the increments. Okay, so to simplify this a bit, because I know that this is a reciprocal of sine and they have, I can use that. I'm going to calculate all my calculations with the sine. Okay, so when I'm filling out my, let's say my XY table, I'm going to let my Y value be negative 2 sine of x plus pi force plus 1 off the page. Let me scoot that over. Oops, let me move this. Okay, so we are going to make an XY table based on this. Now we're choosing to use sine because we know it's the reciprocal of this, and the parent graph of sine of x and the calculations, because they're directly off our unit circle, are much easier to work with. So we're going to do most of our calculations off of this, and then last apply the fact that we're actually graphing the cosecant function of that. Okay, now we said we want to start with our phase shift. So what is our phase shift? Negative pi over 4, I believe, from the previous page. Okay, so we're going to start with our phase shift, and we want to increment this thing, so pi over 2. So add pi over 2 to this. Okay, add pi over 2 to this. Add pi over 2 to this. And that's what we're going to use as our x values, so that we get nice equal increments. And if you want to go off to the side, just do the calculation. So negative pi over 2, negative pi over 4, plus pi over 2, get a common denominator, and you will end up here. So each time I increment it by pi over 2, so that we just have a nice graph. Now let's evaluate these functions. Okay, negative 2 sine, if I put negative pi over 4 right here, what's negative pi over 4 plus pi over 4? 0, and then plus 1. Now let's actually calculate that. What is the sine of 0? Look on your unit circle. 0. And then what's 0 times negative 2? 0. What's 0 plus 1? 1. So all of this equals 1. I'll kind of put the answers, the overall answer in red. All right, let's do the same thing for the next one. So negative 2 sine, what's going to be pi fourths plus pi fourths? 2 pi over 4, which is pi over 2. Now go to your unit circle. And what is the sine at pi over 2? 1. What's 1 times negative 2? Negative 2 plus 1 is negative 1. Continue this process down, and just for the sake of time, I'm going to have 1, and then this would be a 3, and then we have 1. So we're going to do a sketch of these on the next page. Whoops. Okay, now let's go to the next page and plot negative pi fourths 1, pi fourths negative 1, 3 pi fourths 1, 5 pi fourths 3. Okay, so the blue is going to be the graph of our function. We used all of this information in this table to get the sketch of our dotted line, which is of the sine x, and then we recall that the actual problem was asking cosecant. So then we graphed the blue solid function.